The Paraspray Orbit Demonstration Project, or PERIOD in short, is one of the operational grants of the European Union's series of projects on space robotics technologies. Its aim is to increase the maturity of space robotic technologies and define a demonstration mission of an orbital factory capable of assembling a modular spacecraft. For this purpose, 3 European state-of-the-art interconnects were chosen and evaluated as part of a benchmark performed by DFKI.
The state-of-the-art interconnect mentioned are so-called multifunctional interconnects. These are intended to connect components with each other. For example, CubeSat modules that have different functions and are equipped with the multifunctional interconnect can be connected to each other in many ways. In this way, new assemblies can be created. The outstanding thing about multifunctional interconnect is that they have the ability to be mechanically coupled together and are able to transfer electrical power and data between coupled modules. Other features include, for example, the possibility of liquid transfer. In PERIOD, we test 3 different multifunctional interconnects. HOTDOCK from the company Space Application Service from Belgium, iSSI from the company iSSI from Germany, and SIROM from the company Zena Aero Special from Spain.
The necessity of a benchmark stems from the current non-existence of a standard defining a set of features and performance values that interconnects need to comply with in order to be considered for an orbital factory. The overall objective of the benchmark was to compare the electrical and mechanical characteristics of selected interconnects in order to recommend the most suitable one for the envisioned demonstration scenario. In addition, tests were used to document strengths and weaknesses of selected interconnects toward the goal of improving the design as well as operations.
The electrical test helps to analyze the application-oriented functionality of interconnects. This test that we performed in our laboratory environment at DFKI were repeatable test sequences, and these were focused primarily on data and power transmission aspects. In a 4-stage test methodology test, we performed for the functionality of the interconnects, the physical electrical properties of the interface, the data transmission under possible interference sources, and the test of the interconnects under worst-case conditions such as a temporary power failure or data bus failure. From a mechanical point of view, we performed a 3-step test setup with a commercial 7 degrees of freedom robot manipulator arm in different realistic use cases. The mechanical test was focused on the characterization of the interconnects, functional and performance tests for capture range, misalignment, contact retention. Additionally, we performed some tests to investigate the functionality of interface in case of emergencies, such as a case of the relays under load behavior. In order to record the test results in a more systematic way, we use ontological representation that allows discovery of new knowledge. We have created the period ontology as a part of Crocus ontology family, which was developed to facilitate robotic systems. A meta-model was created in this ontology to represent a generic interconnect. The period ontology also helps to distinguish the tested interconnects according to 24 evaluation criteria and the requirements of the different future test scenarios.
Multifunctional interconnects, which allow to connect different subsystems of a modular spacecraft mechanically and electrically, do not yet exist as standardized components in the European space industry. In order to select the most appropriate one for the orbital factory of the PERIOD project, a benchmark was performed on the 3 state-of-the-art European interconnects, HOTDOCK, iSSI, and SIROM. The tests compare the electrical and mechanical capabilities of these interconnects and also set a precedent on how to design future benchmarks of multifunctional interconnects.